Hi all you cool cats and kittens. It's Tanya here from a weird room in my basement. Um, if you don't know what I'm talking about, remind me to send you my Netflix password so you can watch Tiger King. It's hilarious. It's terrible. All together. So this is set theory lesson 2. So in your notes package it's called or, and, Venn diagram graphs. So that seems like it's not a sentence because it has the word and twice, but I'll explain why it actually is a real thing as we go. So I'm a big fan, this one's for you, Jax, of, bad memes about stuff or bad jokes. So we're going to deal with Venn diagrams today. So there are circles and there are diagrams. And what we're going to call the intersection of them, this little kind of eyeball shaped thing, is Venn diagrams because they're diagrams of circles. But as we saw yesterday, like it doesn't always have to be a circle, whatever, not a big deal, but we'll talk more about Venn diagrams today. So it says consider the following 2 sets. So yesterday or last day, I'm going to use the word yesterday because I won't remember, we came up with some definitions. So set, subset, complement, joint, disjoint, universal set, the empty set, whatever it would be. There was lots of different things that we talked about. So here again, when we use the fancy brackets or the braces, our set A is whole numbers less than 20 that are entirely divisible by 3. So that give a whole answer. Oh, my pen's not on. Come on. What color do we want today, guys? Purple. Good suggestion. Thank you for that. So, whole numbers less than 20 that are entirely divisible by 3. So 3 is divisible by 3. 6 is divisible by 3, 9 is divisible by 3, 12, 15, and 18. Oops. So that's set A. Set B is whole numbers that are divisible by 5. It's saying whole numbers less than 20. So it doesn't say inclusive, meaning it includes 20. It's less than 20. So 5, 10, and 15. Again, less than 20 means we're not going to use 20 because 20 is divisible by 5, but we're not going to use that. So list any elements that are in both set A and also in set B. So anything, what's in common? So both set A and B, again, still going to use my fancy brackets there. So what we see is 15 is in both. So it's in set A and it's in set B. It's not, there's no other ones that are in common between both of them, but in set A and set B is the number 15. So what's the new definition that we're going to have for that is called the intersection. So the intersection of the 2 sets is the set A and B. So the language in this unit is going to be very important. So looking at this, we're looking at what's in both set A and also in both set or in set B. So it's the set of elements which are members of both set A and B. That is the elements that are in set A and also in set B. So it seems a little wordy, but again, it's very specific that when we see this word and, we're talking about that it needs to satisfy both of those things. So list all the elements that are in set A or set B. So, sorry, the list is off the top. So this is anything that's in set A or set B. So first number we see is 3. That's in set A, so it is in set A or set B. 5. That's in set B, which is in A or B. In set 6, or sorry, number 6. 9, 10, 12. So we only need to write 15 once. It's in both set A and set B, but the numerical value of 15, we don't need to represent it more than once. So just once for that. And 18. So that is the set A or B. Sorry, just closing a door. So this is a word that we're going to call the union. So the intersection was the last one. That's saying something that's in both. The union is all the elements in two or more sets. So it's the set of elements which are members of set A or set B. So this is a different word. So when we see the word and, we're talking about intersection. When we see the word or, we're talking about the union. So it is the set A, oops, I guess this is the same, the set A or B. And again, anything in common or again, represented by the intersection, only needs to be represented once. Okay, so represent A and B using a Venn diagram. So I'm going to do it kind of like the Venn diagram that I had on the first page because we just have two sets. What a nice circle. That's irritating, hey? Can you see that? I assume you can. I should make sure I'm recording. Did I press play? Okay, good. So our Venn diagrams, the two circles coming together. So I'm just going to represent A and B so I can remember which is which. So now we would put in the elements. So we know that 15 is an element that's in common for both of them. If I felt so inclined to keep switching back and forth, I could do something like this, or if I was our darling Jax with gel pens galore, I could make them different colors if that helps. But I'm just going to go back to my purple because I kind of liked it. Ooh. Oh my gosh. So now putting our other elements in. So again, this is our intersection. That represents the intersection of our two sets. Anything that's not in that intersection needs to be in kind of the rest of our circle there. So for A, we know the number 3 is in there, 6, 9, 12, and 18. You can put commas around it so this doesn't look like 9, 1, 2, or just space it out a little better than I did. And in B, we have the numbers 5 and 10. So these are all of the elements. So in that red circle are all of the elements within set B. In this purple circle are all of the elements within set A. So it says in general for diagrams, for Venn diagrams, if we're just dealing with two sets, we'll look at the intersections and unions of more than two sets. So elements that are only in set A are really in this part. Elements that are only in set B, when we're saying the word only, that means that it's only in set A. It's not also in set B. So this would be elements only in set B. This would be elements in set A and set B. We could also do, so the green circle, I know yours is black and white, but the green circle would be elements in set B. Which is different than this because this is saying elements only in set B. So the green circle encompasses things that are in both A and B and things that are only in B. Whereas, again, this little kind of purple shape that I'm shading in now, that represents elements that are only in set B. Things that would be in kind of our rectangle but not within our circles of our Venn diagram. So those are elements that are not in set A or B. So other things in the universal set that are not included. So for that last question, if your universal set was whole numbers less than 20, something like 1 would be out here, right? 2 would be out here, and 4 would be out here, and so on. So those are elements that are not in set A or set B, but are a part of the universal set, whatever we would define that as. Sorry, I'm just trying to figure out when we learn the notation for this. Okay, it's in the next lesson. You might want to watch the next two, like this lesson and the next one after the other, because they really tie together really well, and then do the assignments after, or do it separately. You'll be fine either way, but they just go together really well. So in each of the following Venn diagrams, shade the region representing the given set. So this is looking for the set A and B. So and again is talking about the, sorry, I started to write the wrong letter, intersection. This shouldn't be here. So that's the intersection. This is the union. So the intersection of A and B. So that's anything that's A that is also in B. The union, so something that's in A or B, would actually be this whole thing, including the intersection. Because something that's housed within the intersection, yes, is in A or B. It's in both, but it still is in one or the other. Not A. So A is represented here on my sheet or on my screen by the blue circle. On yours, it's by the black circle. So not A would be this. But all of this stuff is actually not A as well. Everything that's not the blue circle. So it would be everything except for the blue circle. And so you could call that not A being the complement to A. So it's anything that's not in A that is a part of the universal set. Sorry, if you can't tell my shading, it's just whatever's not in the blue circle. So that's this part of the green and everything that's in the universal set that's not within A. Use the Venn diagram to list the members of the following sets. So it looks like, if I'm reading this right, it's just various numbers. Some of the numbers are in P, some of them are in Q, some of them are in both, some of them are outside. So I'm not sure exactly where this Venn diagram derives from, but we can do it. So it says use it to list the members of the following set. So things that are in P. So the number 2 is in P. The number 8 is in P. The number 9 is in P, and the number 10 is in P. If this is our circle P, we just want things that are in P. Q, same idea. I'll make it a dotted circle as best I can. So anything that's within that dotted circle now. So the number 7 is there. The number of 10 is there. Number 29 is there. So P and Q. And again is the intersection. Things that are in both P and also in Q. Oh, I didn't open my fancy bracket. 10 is in both P and Q. P or Q. So it's something that's in either P or Q or both. So things that are in P or Q. 2, 7, 8, 9, 10, 29. You don't have to do this in ascending order. You see, I always do because that's just my compulsion to do that. I like things organized that way, but again, not really a big deal. Just helps you organize and look for if you've written something down twice, if you have a really big set, you don't want to have 7 here and 7 at the end or something like that. So not P. So anything that's not within my solid circle here. So things that are not within P are 7. 11's not within P, right? 11's up here. So it's not within P. 16 and 29 are all not within P, not within Q. So that's anything that's not in my dotted circle there. So 2, 8, 9, 11, and 16 are all not within Q. So hopefully that makes sense, some of these words. So and, or, and not. You need to be really careful with them and think about, in terms of a Venn diagram, what they actually represent. So in a homeroom of 20 students, wow, big homerooms, 15 take math, 12 take social, and 10 take math and social. Represent this on a Venn diagram. So I'm going to call math my blue circle. It's your black circle, I guess, on your sheet. Unless you print it in color. I guess maybe you guys are richer than the school and could print in color. I have it in black and white. So social is going to be my green circle. So what we need to do, so in a homeroom of 20 students, so looking at numbers, so there's 20 kids in the class. If I look at the 3 other pieces that we get a 10 plus 15 plus 12. Lo and behold, that is equal to 37 students. So saying of 20 students, 37 of them do stuff. That doesn't make any sense. So what we actually need to do is start with the intersection. And again, that's starting with the and part of it. So it's saying 10 take math and social. So we know that there's 10 students that are in this part, are in the intersection. And then if we look at math, so our blue circle for math, it says 15 take math. These students here in our intersection are already counted within that because they take math. They also take social, but they definitely take math. So what we actually do is this is a 5 because in our set math, we have 5 that just take math and 10 that take both math and social. On that same idea, we have social here. 12 take social. Well, we've already accounted for 10 of them in the intersection. So there's actually only 2 that are only enrolled in social when we're talking about math and social. So it says how many students take neither math nor social, or not math and social, not math and not social. Something like that. It could be worded lots of different ways. So what we need to look at is our universal set is the homeroom of 20 students. So we've accounted for 17 of the students take math and social, right? There's 5 that just take math, 10 that take both, and 2 that take math and social. So if we go 20, subtract 17, 3 students do not take or take neither math nor social. So they might be in science and English or something like that and aren't in math and social at this time. So lots of different pieces of information you can get from a Venn diagram. So your questions, that was a short lesson, your questions are in the next couple of pages. So analyzing Venn diagrams, thinking about those words and or as well as not. I'm going to right away do the lesson on intersections and unions. It's a little bit more, so you might want to just watch that right away. It's another short one, and then do all of the questions together or something like that. Okay, see you guys.